Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. We have a super exciting one to dive into. There's been so much exciting research around Retrieval-Augmented Generation. Everyone is building these super cool apps by plugging in their vector databases and their large language models. But now we have this problem that there are just so many options for how to construct these systems. Which embedding model should I choose? Do I need hybrid search? Do I need these advanced query engines? Or even which language model should I use? RAGAS is a super exciting new framework for retrieval-augmented generation evaluation that's really taming this chaos. And I think this is going to be such an exciting conversation. Jithin and Shahul, thank you so much for joining the podcast.
Hey, thanks a lot, Conrad and Erika, for having us. It's a pleasure.
Awesome. And also super excited to introduce my beautiful fiance, Erika, also developer advocate at Weaviate, who's going to be joining this podcast. Erika, thank you so much for joining.
Yeah, thank you for having me again.
Awesome. So Jithin and Shahul, could you tell the founding story of RAGAS and what motivated you to build this?
Yeah, so we were actually playing around with like GPT, and we were building a couple of applications and doing bunch of consulting gigs. And that's when we saw that when we are coming from ML background, right? And there we have the practice of making a baseline, having a test data set, and having a couple of matrices that we are trying to optimize for, and that is the basis of all the experiments that we run. That practice was not there when you're building LLM applications. And because under the hood, models are stochastic in nature, the need for that is very real. So that is why we thought, okay, we needed some way to actually quantify all the performance of all these apps, so that we can be much more confident about the experiments that we are running and actually make sure that there are improvements happening. So there was nothing like that, right? That we could use. So we started off with crafting a few of the existing metrics, existing benchmark data like pair that was there, and we tried to craft it for our use cases. We quickly reached the problem that although these are valid data sets, it doesn't the performance of our applications on that data does not reflect the quality of our users would experience. So we wanted to build something that would be that will give the true reflection of the performance of our applications for the user. So that was the initial problem that we had and that we was trying to solve. And yeah, iterated on that, build RAGAS. Yeah.
Yeah, amazing. So I think if we could quickly, if we could touch on kind of the software stack partnership at a high level, and then later on we'll dive further into like the infrastructure problem of tuning the search knobs. But Eric, if you could kind of explain, the work that you've done with the partnerships with, say, LangChain, Llama Index, and Unstructured, and how we kind of see our relationship with RAGAS and these kind of integrations.
Yeah, so it's so nice to meet the both of you and just like hear the backstory, and congratulations on getting into YC. That's a huge accomplishment, and I'm excited to see where it goes and happy to be talking to you guys in like the early stage. So what I've done at Weaviate is I helped with the integrations with LangChain and Llama Index, and then also working closely with our integrations person Shukri at Weaviate for creating a staging brick at Unstructured. So how can you take the chunks from your PDF documents that is handled on the unstructured side and then fill it into your Weaviate vector database. But most recently, I've helped with the LangServe, adding the hybrid search RAG template to LangChain. And I've seen like great feedback from that, and that's like a great way for people to get started. And then similarly with Llama Index, we have like a few features that I don't want to share that we're working on getting that integrated to. So I just love helping people build and like have these full-fleshed RAG applications with these various frameworks. And I definitely see like the opportunity and like the partnerships that we can have with Weaviate and RAGAS. Just with like the evaluation is so important, and we'll jump into like how to do that and what exactly you're evaluating. But yeah, really excited for the partnership.
Yeah, thank you so much for that, Eric. And I think I wanted to just open the podcast by emphasizing how important that kind of collaboration is for us and how much we're going to be trying to, keep. I think it's so fascinating how, you integrate like hybrid search, or how we are going to interface our APIs to let you tune the vector database. And so let's dive into what particularly to tune and how you guys see that.
Sure. Yeah. So regarding RAGAS currently is mainly focused on evaluating and improving RAG applications. We started off with the RAG because it is the most productionized LLM application up till date. And while coming to RAG, what we did was firstly, when we started off, there were no real established matrices to quantify the performance of RAG systems. The main two components being the retriever and the generator. The retriever, we already know we had retriever recall, precision, etc. But again, in an RAG settings, it was difficult for people to go on and annotate, the correct chunks and everything. So we had to come up with methods to quantify these without the annotated exact chunks. And regarding the generator side, we came up with matrices such as faithfulness, relevancy, which can quantify the performance in the generated side as well. So this was the initial starting. We mainly focused on reference free because the developers were facing issues with annotating, all the samples they had with the ground truth. And then we also moved forward to do some things like answer correctness, where we quantify the correctness of the answer to quantify the end-to-end performance as well. So Ragas currently offers two main things: the isolated evaluation and the overall end-to-end pipeline evaluation.
Interesting. And I did quickly see on the documentation that you were saying like there are existing ways to like see the performance of these, like the recall, precision, all these metrics. But I saw that you guys were like there isn't enough like human annotation or like because we have like a lot of judgment. And we're like sure maybe the precision is high, but what about like just the wording of it doesn't make sense. So like where did it fail in that like in each step? So I think that's really interesting how you compare it.
Yeah, I love that, Eric. I think that's the what's now. You mentioned the faithfulness and the relevance that you prompt the large language model to evaluate the retrieval quality. I think that's the huge what's new about all this. Is in the past we had this like labeling task of document relevancy, right? And it was like super tedious, and you'd have to annotate like 10 documents for every one query, and it's this notoriously difficult labeling task. But actually, even before we go further into the what's new and in this kind of LLM evaluation thing, I'm just really curious, like, so you can tune like the embedding model. You can say, hey, do you need re-ranking, or even maybe the indexing parameters is something we can dive in. I'm just like, maybe if you guys could tell me like how you rank the priorities of like what you should start tuning with your RAG system.
Right. From what we have seen from our customers and users, tuning the retriever is the most important thing. If you get the retriever correctly, if you can get the correct chunks for a given query correctly, LLM is most probably going to answer correctly 95%, 95% of the time, depending upon the quality of the LLM as well. So here mostly I'm referring to an LLM of quality of 3.5 for ChatGPT 3.5 to 4 quality. So there are now, once you have get that done correctly, you can move forward and to optimize for further things like chunk size, where you don't really want to send tokens of really huge chunk size, because it can, one, increase the latency, to increase the cost, three, it can also lead to problems like lost in the middle, where the important chunks actually falls somewhere in the middle and LLM ignore it due to the nature of fine tuning data or something. So this is that will come later, and then if you have to experiment with different LLMs, once you have a baseline, then you want to shift to other LLM or experiment with other LLM, you could always use matrices like faithfulness to see how much change is happening just when you swap the LLMs.
Yeah, and on the retriever side, so like I don't have a stack order of what all like what like on like what all are the most impactful, but just with like what is the easiest to do. Like one thing that I have we have seen like get a lot of get a lot of bang for buck with just how much effort there is like building in a hybrid search, like just having a vector search while it works on like some applications, it's very hard to tune a vector search for your data domain. While just if you're doing hybrid search, because there's also a component of like sparse data, sparse signals also coming in. that gives a massive lift in performance. In fact, that is like one of the questions, right? Okay, how can you actually tune your like alpha score so that you find the best balance between both of them? But in general, getting a good hybrid search is one way. Having a good re-ranker is another way. Also, there's a lot of easy wins at how you actually structure the data. So based on how like depending on use case, how you make sure the data is much more accessible. Because right now, all the data is like people just like without doing any formatting, they just use the data as it is, and there we find that it makes the retriever much like it makes it harder for the retriever to bring like correct size. There's subtle bugs where the formatting of the data is wrong. Because of that, the even the LLM cannot like extract the correct information. All that part can be solved with good like basic data cleaning. And yeah, those are like three quick things in
Yeah,
my mind.
yeah. Just adding one more point to it. If you want to really, if someone wants to really push the boundaries of RAGs to, enable questions like that can even query structural questions that involve structure. For example, if I'm having a RAG that has all the papers, but I'm going and asking the interface to for a question like give me the summary of last table in attention or is all you need paper. So here the RAG actually needs to identify the last table in the particular paper. So if you just push the whole chunk together, it is going to miss the structural information, and which can be very important for these kind of questions that requires the structural information to identify the correct chunk. So all of these are very very new things regarding drags, and these are the aspects people who are trying to push the boundaries with drags are trying to explore. But these are very exciting experiments to run.
Yeah, I think there's so much scope to it. I think that's why the opportunity for Ragus is so compelling. And so yeah, the tuning of chunk size, I find that to be really interesting, because then you kind of have like this end to end system. Like, I think as unstructured Noom AI, we're seeing all these players in the data ingestion layer grow, and so it's like you're kind of like orchestrating Weaviate as well as these other things, as well as the embedding. Like, Weaviate has the embeddings in the modules, but the chunk tuning. But anyway, so yeah, there's so much like to the end to end, and the adding structure to your schema. I also find that topic to just be super fascinating. I haven't seen too many people really experimenting with, like, personally, I love this idea. And maybe Erica, you want to hop in on this, because this is something that we talk about a lot. Is like having, like right now, I think, yeah, people just put all their chunks into one big class, and it's like, documents and like just content chunks. Whereas instead you could have like, this is what I know about Kubernetes, this is what I know about RAG, this is what I know about embedding models, and then the language model has this prompt, or you have some kind of like classifier that takes a query and routes it to one of the indexes. Yeah, Erica, maybe if you want to hop in on how we see that kind of like multi-index search and the structure of your vector database.
Yeah. So for one of the episodes that I made on Llama Index was covering their various query engines, which is extremely interesting just because there are so many options, and like the best one to use is really dependent on your application, your data, how your data is structured. It's like there's too much to it. I feel like that at some point it's overwhelming. So yeah, I just wonder, like, how do you see, would Bragus make a recommendation on like which query engine to use? Like, should you use the sub question query engine where like a very complex question is decomposed down into two questions, or should you maybe use this SQL router query engine, just because like you do have like the SQL database and then also your vector database? It's just like, I feel like there's so much to cover in that. Um, yeah, it's like so complex that I guess one question that I wanted to ask in addition to that one, but I feel like this flows a little bit nicer, is do you see Ragus as like the full evaluator for the full pipeline? But then when you really drill down to like the chunking, the retrieval, and then the large language model, like the generation of the text, like would you make recommendations and like evaluate each step, or would you do it as a whole? Because I feel like if you do it as a whole, it's like, well, your chunking was wrong, but then and the next one used the wrong query engine. It's like, how do you see that with Ragus?
Right. So our vision of Ragas is to build it as the open source standard for LLM application evaluation and improvement. So this will cover RAGs, and this will cover every aspect of RAGs, like the query transformation, chunking, and the LLM retrieval phase, and the LLM also. So RAGs as itself as an enterprise use case, what we have seen is in most cases it's not purely RAG. It's bringing the whole value. So, for example, in most cases there will be some small agent action, or maybe there are some other small LLM actions that can complement the whole experience of the user. So from building an application point of view, RAG is one of the most important component of this application. But again, there will be other aspect as well. For example, agents. There will be small kind of agents. There will be other application where RAG is not clearly needed. All these will come in. So RAGAS will in future will provide evaluation and improvement infrastructure for building such LLM applications. So that's where we are heading to.
So my question is, I really want to kind of get to the bottom of this multi-index kind of thinking, and just I see kind of two dimensions to it, where it's either you're adding structure to kind of vector search, or you're also kind of orchestrating the existing infrastructure for what enterprises might have with, again, this kind of like data mesh, data lakehouse thing, where you have like all sorts of different data systems, like maybe a a Redis cache, or like you're in your SQL Snowflake or whatever, you have all sorts of different tables, and so just kind of that whole scope of searching through all these different indexes.
Yeah. So, like currently, we haven't thought about that problem a lot, because even though like the exactly like what the exact problem that Erika said was a origin story. Like we were like there's all these like different indexes. We don't actually know what actually gives the best performance. But we haven't actually done a lot of research on okay which works better, because what we have seen is that it depends on your distribution and like your use case. So if like with a few clients who have like very simple retriever like very simple data sources, like a very simple like RAG system works, so you don't need a bunch of like complication. And there like even like some sort of basic tuning is like important. Advanced use cases, I don't have a favorite. Depends on your use cases. But hopefully, like what we do is like okay, even the retriever step, right? We have like a couple of matrices that give you the precision and record of the data set, and we also have a tester generation that will make sure that okay, it's much more easier for the user to actually build a test set that you can actually test against with the RAGAS like scores. So those are like two things. Like those are like that's the approach that we have. So we provide the tools, but we haven't done like work with a lot of people that we are. This is something that we're trying to do to actually figure out. Okay, in this situation, these are the indexes that actually work. In this situation, these are things that work. But I think Shahul can provide like what are the metrics that we currently have with for the retriever that people can use to actually evaluate this. So you like the listeners can actually try it out for themselves.
Right. So for retriever, we mainly focus on two things: retriever precision and retriever recall. And here, the precision mostly, the recall is the normal recall that we everyone knows. I mean, how much recall. But the recall here is calculated using the annotated answer, not the annotated chunk, because chunk annotation is very hard. So that's retrieval recall. And then we have retrieval precision, which is also rank sensitive, because people are trying to use things like re-ranker. Everyone mostly in enterprise use cases, mostly everyone uses re-rankers, and they would want to mainly know the difference between the precision if they are using re-ranker and if they are not using re-ranker. So, and this difference mostly comes up when in the ranking of the chunks, because then after using re-ranker, what we see mostly is the chunks mainly go up in the ranking, and without this re-ranker the chunks will be somewhere down the lane, which can also cause the LLM to ignore these important chunks. So these are things that we focus on retriever. And regarding how we facilitate this thing is that okay, what we saw with developers is that developers have systems in which they have data coming in from different sources, and to build test data sets for testing all this dynamically is a human. It can be very time consuming, and it's not an attractive job either to sit and build all these questions and annotate answers. So what we facilitate there is that if you have a data source, you can connect that data source to Ragas, and Ragas has a paradigm through which what we are aiming to do is to create questions that are very much similar to what is seen in production. So if you see in production, you will have questions that are of very diverse nature, not that. And this is what we are trying to synthetically replicate using LLMs under the hood, plus some paradigms that we have developed.
Yeah, amazing. So there's a couple of things in that, and I really want to explore the ranking thing a little further. Eric, I think we wrote our blog post on ranking models. Do you remember when that was? I think that was like April, maybe.
Yeah, earlier this year.
Yeah, earlier this year. But so to me, the question is, there's this trade off of how many to retrieve than to rank. Like if you have a high capacity ranker model, it's slower but more accurate, and so maybe you only need to re-rank like the top 10 with that compared to like a faster faster re-ranker that you retrieve 100 and then re-rank with the faster one. So hopefully I've painted this picture where you have the how many to retrieve, and then the re-ranking, the trade-off is accuracy for speed generally. So I mean, tuning that kind of thing is such an interesting question, because it's like you're kind of tuning like which re-ranker to use as well as how many to retrieve. Maybe there's this question of, is training your, like you mentioned, generating the synthetic queries, and we're going to really dive into that in a second, because I think that's kind of the huge what's new about all this. But I think you can also use those synthetic queries to train your own re-ranker model. You could train your own embedding model that way as well, but then you have to re-index. You have this like shallow layer, but I think training the re-ranker is a little easier for now. So you could add that in the loop, but so maybe my question, in addition to kind of the whole topic and asking to comment on the whole topic broadly, but my question would be like, how important is that idea of the tuning the re-ranker capacity and how many to retrieve to then re-rank? Like, where would you put that in your priority list?
It is certainly it will be certainly in the high priority list, because re-ranker again can there is because of the nature of bioencoders which are used for the retrieval purpose, it has a limitation there. So what re-ranker brings into the picture is the ability of the cross encoder models to take these retrieved chunks, maybe top 100, and to figure out which top 10 results or chunks are the ones that is the best. That's a picture of re-ranker, and that is why I think re-ranking is very very important. And because there are open source developments in embedding space, you can actually train your re-ranker if you have you can even synthetically create data and train your re-ranker, and this can really really improve your pipeline as a whole without much cost. It might be like, even for fine tuning plus doing some synthetic data generation, this experiment will cost, in my estimate, less than $1,000. So but the impact of this is really really high on the quality of RAG as well. So this is something of really high priority, and something that I would really looking forward to more people doing it in the future, so that I think in general people are trying to fine tune open source LLM side rather than trying to fine tune the embedding side, which is much. The embedding side in the RAG is the one which you can easily replace, especially the re-ranker, and then also get much better output as well. So that is something like a low hanging fruit people are currently not much focused on, but I think people building RAG should focus much on that.
Yeah, that's one aspect that I haven't really heard people suggest. But yeah, like you said, the impact is very high. And yeah, just awesome. It's a great suggestion, and I can only imagine what else you guys have coming.
Yeah, I love it. I think fine tuning the LLMs is it's kind of easy, right? Because you just kind of like language model your text, and then the instruction following. it really looks like I've been playing with fine tuning language models for this Gorilla project, and so I've run the notebooks with the PEFT library and done that a few times, and the instruction tuning is also just really simple to set up your data. So I mean, you could kind of use the same framework for training your own re-ranker, where you just kind of language model it, and then you have the relevance score as like the last token that you're predicting at the end of the candidate document relevance score. And so yeah, I do think just tuning re-rankers is something to really evangelize further. But then I'm really interested in this kind of orchestration of RAGAS and Weaviate, because I think training re-rankers might be out of the scope for both of us, kind of, and we're looking for that other partner that we say, hey, we think that we need a new re-ranker. Here's the data, and so you would have that orchestration of like a model training component into also kind of the evaluation stack with like the chunker embedder vector database. So yeah, it's such an interesting end-to-end stack. Cool. So maybe we could transition into, because I think this topic will touch on everything we've already started talking about, but this kind of like infrastructure problem of testing multiple like vector indexes or multiple search index configurations. Because like maybe to set the table, like if you want to compare the OpenAI model with the Cohere model with sentence transformers, you've now created 3 indexes. So your cost is going to be, not 3 times, because they're not all the same dimension sizes. And we could, nerd out about the details about exactly how much each index would cost. But you have this kind of orchestration problem of managing all these experiments you're running.
Yeah, running them, yeah. But the first, like, so if I was like trying to figure that out, the first aspect is obviously getting a good test set, right? That'll ideally be a reflection of the user, the like what I would see in production, and that's like the first major goal. In fact, like even the clients that we talk to, that's the first thing that we actually try to facilitate, so that that test set is good and we have a good representation of what, like we have a good representation of what the like like what you're trying to optimize for. Other than like otherwise, like okay, ragas, like so when you like if you're trying to evaluate ragas right now, the default what we are the LLM that you're trying to use is OpenAI, and you can actually connect with any other like LLM that you want. All of them, like all of the possible endpoints are supported, but we like do most of the experience with OpenAI. And one thing that we do is we try to like break down the problem into much smaller chunks. So if you are actually trying to figure out the faithfulness of the different the indexes that you have, we actually break it down into 2 steps, which is okay, the out of the generated answer, what are the number of statements that are there, and from the given context and these number of statements is how many of these statements are supported from can be derived from the context, and that is how we actually score. So we use so for from an for Raga's point of view, you need access to a data set. You need a good data set. You need LLM that can is able to perform it, and then you are like able to scale it. So like what we do is give the data set into your pipeline and make sure that you get the input query that is given, the retrieved context that you got back, the generated answer that is there, and if there is a ground truth in the answer, you use that, and these 4 fields you give them back into ragas, and ragas will give you the scores. You can choose the metrics that you want. So the metrics will, like if you want to evaluate, if you want to compare between like OpenAI and Llama 2 or something like that, you want to, that's the generator part, so you can use metrics that focus on the generator part. But if you want to compare like sentence transformer with OpenAI embeddings and various hybrid search, all 3 things like that, you can use the retriever metrics that will be much more relevant and score that. So that is the point of view. Like that is how you would like set up the infra for Ragas to do the evaluation.
Yeah, just adding more point. If you want, if you are, or if any of the people hearing are using frameworks like Llama Index or LangChain, you can easily do it without preparing the data set by just plugging Ragas into the evaluation frame, because we have integrations with this framework, so it will be much easier to use it if you are using these frameworks.
Interesting. I love that Ragus easily has these integrations with LangChain and Llama Index. But another thing is like covering the visual aspect of it, of like the full pipeline and like where the problem is. And when Connor was like, "Oh, would you like to join the RAGAS podcast?" He was like explaining to me what it is. We were just like chatting about it. And I was like, wait, so this is like the weights and biases of RAG. And I think that's like such a great comparison. And it's cool that you guys come from this machine learning background because you understand like what weights and biases is and how it benefits people setting up these experiments. So this is like definitely something that we need in the RAG world and application is this like visual aspect of like seeing the evaluation of your app. And I don't know, it's really neat. I don't know if you guys also agree that it's weights and biases comparison. That was my epiphany.
Yeah, maybe. Yeah, so maybe one more thing about the weights and biases analogy that I like a lot is I see in weights and biases you have like the callback manager. So you're training each of these deep learning models. Each one generally needs at least one GPU, and so you run it for a while, and then you have like this orchestrator node. So you have this like two infrastructure problems where you have the main managing of the GPUs, and then you have the managing of the central thing that's like, how's all that going? And so I see kind of index building as kind of a similar problem where you also need to like wait. Like if I'm going to test Cohere vectors versus OpenAI vectors for 10 million vectors or like some particular configuration of product quantization or HNSW, I'm going to need to like wait a little while before the index is fully built and I can fully test it. And it's kind of because I understand that like there's kind of like this full stack where you can evaluate kind of the question answering part, and you're just kind of looking at the answer that comes out, and you say, is this a hallucinated answer? And then also maybe the language model is what tells you if it is hallucinated, and that's quite novel. But there's also like this building of the index's middle layer, which is where I see like where I kind of see the super exciting problem. And so I think kind of the weights and biases. Another thing that we are very curious about is like I think something that appeals to us a lot about RAGAS is the code. Like as we opened up, and Erika mentioned like her experience with integrating our APIs into open source Python libraries. Is the code, the abstractions are great. I'm curious like what your future plans are. Maybe building like a visual GUI, like something that would really explain this tuning process.
Yeah. So one thing like at the future plans currently we want to make improvements on the test generation part, and the next part will be trying to answer the question of how can I actually use the user feedback that is coming in after you have actually deployed into production and complete this loop and make this a continual learning framework for your RAG pipeline. And that is the direction that we want to go. We want to make sure that this is a continual learning framework for our RAG pipelines and then possibly LLM applications. So that's the direction that we are possibly going. But the current one shortcoming that all of our users are saying that there's no way to actually visualize all of the results that are there. That is something that we are interested in, but then currently there are also tools there are LangSmith. There are also tools like weights and biases and you can also have your Play-Doh, NumPy, Jupyter notebooks. So what we expect the users would do, we want to give them the flexibility to use the tools that they are actually using right now, and then try to figure it. It's current that is a bit of tricky because then it's the user's responsibility to leverage the information best and get the insights that they want. So yeah, we want to we will provide hopefully some more documentations and how to's on that. But that's our general theme there. We are giving the users the tools and the flexibility to use the tools that they already have to tackle the visualization part. But we want to be the continual learning framework for RAG pipelines. So that because all of these are combined. Okay, you have something, you have a test set, and you have evaluation, or you have a setup that is working when you're developing it. But when you go into production, you get the real user data. And a lot of developers actually are still not sure of how can actually make the maximum use of this. Everyone is using simple metrics like thumbs up, thumbs down. There are a lot of there are minimum metrics that you can actually track, and then all this come back into the development process to build a better test set. That okay, you figure out, okay, these are the situations where the users are not happy. Now in the test set, I should make sure that these cases are covered, and then I add them into a test set. then you run them with the RAGAS metrics and see that, okay, for these experiments, we see that the retriever is not performing very well and the recall of the retriever is not good because that is somewhere the measurement is not good. Okay, so how can I improve that? Then I maybe tweak some things that in my application to improve that. And then I go back, put it back into production and see the results. So that is the end goal that we want to achieve.
So with that, maybe I'm not like super familiar with LangSmith. Unfortunately, I understand it's like you're visualizing like a prompt. So I understand LangChain is like chains where you have like 5 language model calls in sequence, and so you're kind of visualizing what happens at each step to see like like if I have like this editor prompt where it first parses each paragraph to like rephrase this, and then later on it will merge them or something like that. So maybe if you could help me understand further, like. Yeah, because I think this whole thing can be so complex where you have like just retrieval and it's like precision recall, or you have like these LangChain Llama Index type of like agentic, I want to call it, where you have like 5 or so language model calls sort of on top of it. Maybe if you could just further explain kind of like the relationship between LangSmith and RAGAS.
Yeah, so currently like LangSmith and LangFuse and all the other like LLM ops or LLM observability tools give you like a view of the visibility of what is actually happening inside your application. So suppose if I have a complicated RAG system where I have some sort of query transformation where I have like multi-hop questions. So I'll give an example. So suppose I have a multi-hop and a query transformation inside my RAG. I have a first query that is coming in, and then I'll ask the LLM to actually break this down into like smaller queries or figure out, okay, what are the queries that I need to run that to in order to actually come to the answer. So that's the transformation process. And suppose it generates like three additional queries, and then and you run those queries with your RAG systems, and you have to log, okay, what are the chunks that I got for each query, and then how did I actually use that bring out the answer. And so it's like a trace span of all the internals of LLM application, and it is exposing it in a nice UI. So as a developer, it's much more easier to reason about like what's actually happening in my app.
So with Ragas, how we do have what we provide is that people can, okay, now there are all these visibility tracing tools that developers can use. What is lacking is a workflow and metrics to run or make this all work at scale. So that under that spine is what Ragas provides. And people, for example, now can use Ragas matrices with LangSmith, where whatever visibility tool they use. But the metrics or the underlying things like test generation, the making sense out of feedback, all these things will be provided by Ragas.
Yeah, so like I can give you an example. So we were working on this one blog post with LangFuse, where so LangFuse, what you can do with, you can export, like suppose you have like traces, you're logging all the traces into LangFuse. You can export off like the whole trace or a part of a trace, and you can ask Ragas to score like with the matrices. Here, one thing is that you can only score matrices that are reference free. We can like dive into that if you want, but you can like use the metrics like reference free matrices to score all these different logs. And if you find that in any of these like traces the performance is not good, you can click through the UI to figure out what happened internally. So that is a production like online monitoring setup that you can actually do with Ragas today.
Yeah, I think that vision of visualizing the multi-hop question answering, where I love the did Thomas Edison use a laptop example of multi-hop question answering, where you break it into when did Thomas Edison live, when were laptops invented. So you really paint the story clear. Where I have this sub question query engine in our Llama Index investigation, and you break it out into these 2 questions, and then you look at the the retrieval here. So I have a couple of kind of future looking questions. Shahul, you mentioned the kind of metrics, and I think this whole like using the language model to evaluate the search results. I know some people, they're like, you're using noise to evaluate noise. Like some people have this kind of adversarial take on this kind of perspective, but to me, kind of a vision for Ragus that is kind of is quite exciting is like fine tuning a smaller language model just for the sake of faithfulness evaluation. Are you guys thinking about this?
Right. So exactly. So this is one direction that we are thinking about. So we have, we can think about it in two ways. Either, we can have smaller models for evaluation, and or we can have the smaller models for just for gaining insights from production data points. So these are the things that will hopefully will do in the future, that we'll have these custom models that can do these kind of tasks, specific tasks that can enhance the visibility of the LLM application, and how it's doing in not only offline evaluation, but how it's doing in production as well. So yeah, I think it's completely possible, and with the advancement of open source, with new and better, cheaper foundational models coming in, these kind of tasks can be very well achieved with smaller models, as very similar accuracy of these huge models.
I guess another like future looking thing, touching on what you just covered, is what do you think of having agents that are assigned with testing the faithfulness? I know it's like you can fine tune the LLM, but what are your thoughts on agents? Because I feel like right now everyone's like, it's too early for agents. Like, just like wait a second. But I don't know. What do you think for the future? Do you see that as a possibility?
Sure, sure. As I said, the value and the total experience of creating an LLM application comes with not only RAGs but also agents, and with other component, but other things that is possible with LLMs, right? So again, if you have some specific aspects like agent or any agent behavior, it should be tested. It should be tested and evaluation at scale. So it is something that Ragas will tackle in the future. We are also figuring out, it's these are like open questions, how to actually evaluate or test agents, because this is where these are very new, very new, capabilities of LLMs. So again, yeah. So in future, we will hopefully tackle that as well and include that in the Ragas stack, so that it can Ragas can be the place for LLM application evaluation and continuous improvement.
Yeah, I have a question on this. I really want to dive in. So I've been super interested in the Gorilla LLMs fine tuning a model to use Weaviate's query APIs, and I'm super curious about this idea of using tuning APIs as well. So maybe to set the stage a little more. So Weaviate has this GraphQL search API where you can combine things like a filter with hybrid search, and then the particular alpha parameter, so on. And I imagine like with like agents and agents that tunes RAG systems, is that Ragus has these APIs, and maybe if also we could so like I don't think you could describe all the APIs of Ragus into an OpenAI JSON functions. Like I think it's I think that's only for very simple functions like get the current weather. I don't think the agent can control Ragus just with the JSON of the of the APIs, but yeah, so I do think this is an extremely future-looking question: is agents that are like using Ragus to tune a RAG system. But yeah, I'm just curious if you guys are interested in that.
Yeah, like Andre Kapati, like I guess like 2 years, 3 years back, like told this like project like Operation Vacation, where the whole idea is that okay, you have a ML, like you have your monitoring solutions that is monitoring like your performance of the application, and then you use that data coming out to actually improve your model also. So as a data engineer, you don't have to you just have to oversee the if it's everything is working like properly, and that's the future that we also hope. Like ideally, okay, you set things up and everything like naturally happens because there's data everywhere that's coming in. It's like it's definitely possible. It's not it's just that the yeah, it's just okay, just the process of experimenting it and trying to figure out because people have already done it. So yeah, that is something that we are also super excited about having an agent that actually optimizes for you.
Yeah.
We are like yeah.
Uh,
Yeah. Yeah, I love that question. Like this whole kind of like meta AI, building AI recursively, self automation, all that those kind of topics.
Yeah.
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 So one more kind of anchoring, future looking question I wanted to get some more perspectives on is this long context RAG thing? And Erica, maybe if you want to kick it off, I know you told me a ton of new stuff about this just this morning, and we could just continue that.
Well, I guess this isn't super forward looking because OpenAI just released GPT-4 Turbo with the 128K context window. So It's present. I just wonder how you guys see like the evaluation with such like a large context window. Greg Camerad, I hope I said his last name right, just covered an experiment of testing this long context window and seeing how well that it performed. And turned out like you still have obviously the lost in the middle problem with the output and just like the performance of it. But yeah, so what are your thoughts on these large context windows? Are they the future? Should we still like have these chunk sizes and like the structure of our data? Yeah, what do you think?
Right. So regarding larger context and the lost in the middle problem, I think the lost in the middle problem is something that can be solved because I think it might it occurs partially due to the nature of maybe the fine tuning data because if you see if you even if you fine tune for longer context lengths what happens is that the model does not really need to use the context somewhere in the middle to predict the next token at the at the end maybe like so I've fine tuned ton of models, and this behavior is something that I've observed when fine tuning for larger context. Because if you ensure the data quality while fine tuning, and if the data has such dependencies, it will naturally align its attention score values and vector values so that it will use the it will identify information anywhere in the context window. So surely, I think in very near future that will be solved. But the case of longer context windows again, now we know with the embeddings we know that how to enlarge context windows up to 128K. I am pretty sure that even OpenAI has followed very similar ways to enlarge their enlarge their context lengths. But again, I am not sure what is the use of context length after 32 or 50K window because I haven't seen anybody use it, or I haven't really seen any application where that is very, very usable and scalable. So yeah, I'm skeptical towards the enlargement of context window beyond a particular point because I don't at this point I don't see any use for it after 100K or even less.
Hmm, interesting. Yeah, I mean, that's a great point. I think it's like in the beginning stages of testing it out and like, are these large, long context windows even valuable? And like, at what point should you cut it off? Um, yeah.
Sure. Yeah. Yes.
Yeah, and I think earlier we talked about multi-index tuning and like having multiple indexes, and I think that's also quite related to long context RAG because I really like the example of like with Weaviate features. If someone has an app and they're saying, I need to add, can I add can I add whatever Weaviate offers for recommendation to my app? And then it retrieves like 50% from your code base, 50% from the Weaviate documentation, and then like stacks these up into like a 50K context window. And I also really, I think with the RAG, it's quite interesting to like, like I think a lot of us, as we talk about like recall and precision metrics, we're mostly talking like recall at 10 when you're then putting it into question answering. But if you could do recall at 200, now you don't need to be as worried about I think the re-ranker thing might lose some value if you only need recall at 200 because that was the setup to begin with. Yeah.
Yeah, I
I, I,
agree with that.
I
Yeah.
do think that's an interesting idea of having like take the Weaviate documentation and then also the blogs or like any other information that could help build like how you can include Weaviate in your application or something like that. Just like maybe you take like 150 um, objects, like relevant information from the documentation, and then like 50 from the blogs. It's like, how do you weight that if you are going like the multi-index route? It's like similar to the hybrid search problem. It's like, how much should you weight alpha so that you have like the best performance? Like, should it be closer to the keyword or should it be closer to vector search? It's like, yeah, just like a mesh of opportunity. I guess.
Yeah, I think that was just the perfect, and yeah, like now tuning how much to search from each of the indexes, relating that to tuning the alpha and how much to weight BM25 and vector search. Eric, I love how you compared RAGAS to weights and biases for RAG. I don't know if you guys are gonna. I don't know if that'd be too adversarial of a slogan, but, but yeah. Jithin and Shahul, thank you so much for joining us on the Weaviate podcast. I thought this is such a fun discussion. I'm so excited about the future of this technology, and we're going to be, sending messages about ideas that we have to help contribute to this. And congratulations on Y Combinator also. It sounds like such an exciting journey. And thanks again.
Yeah,
Thank you.
thanks, Conor and Rika, for having us. Man. It's like exciting times actually. Like to be able to work on like all these are like opening up opportunities that we could like we would even a year back we wouldn't even imagine. So like exciting times to live in.